Hey guys, welcome to Unit 9, Section 6. Today we're talking about perimeter and area scale factors. So we've talked about scale factor in the past. It's going to look a little bit different specifically for area, but the perimeter one's going to be pretty similar. So the theorem states that if two polygons are similar with the lengths of corresponding sides in the ratio of a to b, then the ratio of their areas is a squared to b squared. So when you're looking at and you're talking about perimeter, you want to think of like just comparing the side lengths, similar to how we did before when we were talking about scale factor. So the side length of polygon 1, the first one is a, and then we compare a side length that corresponds to a from the second figure, and then that's all we have to do to write the ratio. Now for the area though, it is going to be area squared divided by a squared divided by b squared. So you're comparing that side length, but you're squaring it first. So let's go ahead and compare these with a couple more concrete examples. So the following triangles are similar. Find the indicated ratios. So the ratio of red to blue is the order that we're going. So what you want to do is take a side from the first figure. So here's one from the red one. And then notice that would have to correspond to the other value over here, 12. So if we wrote this as a fraction, it would be 8 to 12. And then we can reduce this. So 4 goes into both 8 and 12. It would go into 12 3 times, and it would go into 8 2 times. So the ratio is 2 to 3. And that would be the scale factor from the first figure to the second. And then the ratio of red to blue for the areas. So now all we have to do is take our scale factor from the perimeter part and then square each part. So this is going to end up being 4 over 9. And that would be the scale factor in terms of area. The next one says the polygons are similar. Find the ratio shaded to unshaded of the perimeters and of the areas. So find the unknown area. So this one, we want to first think about the perimeter part because we're going to find two different ratios here. So I'm going to write perimeter, or I'm just going to write P equals for the ratio for the perimeter and A equals. Now we know two side lengths that correspond to each other, so that's all we need to do for the perimeter part. So we can just write it as 2 shaded to unshaded, so that's goes with the shaded one, and then 8, and then we can reduce this, and that's just going to be 1/4. So the perimeter ratio is 1 to 4, or 1 over 4. And then the area one, we would just need to square each of those. So if you're going to square 1 squared over 4 squared, that's going to give you 1/16. So 1 over 16 is the area ratio. So what that means is we could fit 16 of these small shaded pieces into the area of the bigger figure. And now we want to find the unknown area. So with this, we want to compare. We already know that the area of the small figure is 3 feet squared. So we could set this up and set up a proportion. So it's going to be 1 to 16, since we're comparing the areas, is equal to 3 is the area that corresponds to the small figure. And then if we don't know what that is, we can just call it x, just like when we were setting up proportions before. So it's going to be cross multiplication because we want to solve. So 1 times x is just going to be x equals, and then 3 times 16 would be 48. So the area of the bigger figure would be 48 feet squared. All right, we got another one here. The polygons are similar. These look to be parallelograms. Find the ratio of shaded to unshaded of the perimeters and of the areas. Then find the unknown area. So just like what we did in the last one. So we'll set up two different ratios. We do have two side lengths that we can compare. This time though, the bigger number is on top. So we are comparing 18 to 10. So those are both even numbers. We can reduce this to 5 and 9. So 9 to 5 is the ratio of the perimeters when we're comparing the sides. And then the areas, we just got to take 9 squared over 5 squared. We get 81 over 25, which is not the nicest fraction ever, but it works. So here's part of what we need to do, now that we want to find the area of the small unshaded figure, what we're going to do is set up our fraction, 81 to 25, and that is going to be 162 is the area of the big figure. So that's got to go on top, and then we'll call the bottom x. This one you probably want to use a calculator. Let me just split screen this really quick. So this one we need to cross multiply. We're going to take 81 times x and then 25 times 62, or 162. And we get 4,050. Then we have to divide by 81. And we get a nice number of 50. So that means that the area of this one would be 50 meters squared. And that would be our other answer that we wanted to find there. All right, 2 more here. Now these ones don't have figures, so keep that in mind. You might want to draw yourself a picture if you need to. This one, it doesn't even tell us the shape, but as long as we know the ratios, we should be able to solve it. If the ratio of areas from one polygon to another is 9 to 25, find the ratio of the corresponding sides. So this time it's giving us the ratio after we've already squared it. So this would be a squared over b squared is the 9 over 25. So if we're just trying to find a over b, we just need to go backwards. So we're going to take the square root of both of these because we want to find like the perimeter ratio. So this is just going to end up being the square root of 9 and the square root of 25, which is 3 over 5. And 9 and 25, hopefully you recognize that those are perfect squares, so kind of leads you to that answer. The next one, if the ratio of corresponding sides from one polygon to another is 10 to 15, find the ratio. So this time, the problem here is 10 to 15. If we write that as a fraction, we can reduce that. So that's what we want to do because we want the simplified ratio. So 10, we can take a 5 out of that, be left with 2. Take a 5 out of this, be left with 3. So the area, or the ratio of perimeters and side lengths is 2 to 3. So then we just want to square each of those. So 2 squared over 3 squared is going to give us 4 over 9. And that would be the ratio of the areas. Okay. So that is it for the notes. Go ahead and try the following worksheet for 9.6.